In this video, we'll be talking about similar figures. So we're going to start with defining some of our important vocabulary. Congruent figures are two shapes that are the exact same size and shape, while similar figures are shapes that are not exactly the same but have a lot of features that are the same. So corresponding angles will be congruent, or the same shape and size, while corresponding sides will be proportional. So the difference between what we mean between congruent and similar figures is you can think of congruent figures like two triangles that are the exact same size. So maybe they're like twins, okay? Whereas these two triangles look similar, but one is much larger than the other. So this triangle has different measures than this triangle, but their angles will be the same. So these are kind of more just like siblings. And so when we relate that back to our math vocab, the ones that are exactly the same are our congruent figures. They're going to be the exact same size and shape, where all the angles and all the sides are congruent. But our siblings, or our similar figures, are just going to have angles that are congruent, but sides that are different. So maybe these sides are all worth 6, but on the smaller triangle, each of those sides are worth 3. On these triangles, all their sides would be worth the same measure as each other, and they'd be the exact same size. When we talk then about corresponding angles and sides, those are the sides and angles that are in the same position among similar shapes. So for example, this angle is on top, just like this one is. So those angles are corresponding. Or this side is on the left and this side is on the left. So we'll talk more about how you can identify them when they're not facing the same way, but that's the general idea of what we mean by corresponding. So now we're going to look at some geometric symbols. The first one that you're going to see is this triangle shape and then 3 letters. So we would call this triangle ABC. And we have a picture of it on the right here as an example. So you could name this triangle ABC. You could also name it triangle BCA or BAC. Any order of those 3 letters is fine, as long as you're using capital letters and the triangle symbol. Our next symbol that we have is this kind of like swirly wave. It's sometimes called a tilde, but in math we say this is similar. So you would say in this example that triangle ABC is similar to triangle DEF. That means that these 2 triangles, which you can see are not the exact same size, are going to be similar to one another. So remember, we defined that above. They have angles that are corresponding, that are congruent. So notice how A and D both have 1 marking on them, so they're going to be congruent angles. And then we have angle B and angle E, which have 2 markings. They'll be congruent. And then our last pair of angles in this are C and E. And those all have 3 markings, or sorry, C and F. Those ones will be corresponding and congruent. But then when you check out their sides, all the side measures are not the same. So 6, 9, those 2 are both in that same position on the left side there, connecting the yellow and green angles, but they're not the same exact number. So these triangles are just similar and not congruent. And to write them with our geometric symbols, we use this kind of like symbol with a wave shape. Then we have something where you have 2 letters with a line above them. So we pronounce this as side DE. And so we're just talking about a specific side on a shape. So if I were to find that on my shape, I would connect the corner D with the other corner E, or the 2 vertexes right there, and we get the side DE. It's 15 meters in this diagram. The next one we have is kind of like part of a triangle with HIJ, and that's pronounced as angle HIJ. So it's not the whole shape, it's just a particular angle. So when we read this, we need to pay attention to the order. To create the angle, we'll start at the first letter, which is H. We'll go down to the second letter, which is I, and we'll end at the third letter, which was J. And so we open it up with angle I, or sorry, the point I being that middle part. So the angle HIJ is this particular angle down here, right next to the letter I. So whatever letter was in the middle of the angle name will be where the point or vertex of the angle is. And then in our last symbol for today, we have this symbol that kind of looks like our similar symbol from above, but now we have an equal sign underneath it as well. And so this is going to mean congruent. So that's when we have our 2 triangles that are the exact same shape and size. So something that you'll notice here is in these 2 triangles, they both have 1 marking and this angle up top. Then they both have 2 markings on the ones on the sides, and then you have 3 on the bottom. but notice how these green angles on either of them that I just highlighted are on the left and right. So these triangles aren't facing the same. So when we talk about corresponding sides and corresponding angles in this particular example, we want to use these markings on the side of the shapes to help us. So I can see that this little tick mark, there's one little line. That means it corresponds with this side that has one little line. The sides in the middle that have 3 lines, those will correspond to one another. So it's not always just right and left sides, but it could be dependent on which way they're facing, where they have the markings to help us decide as well. So now we're going to talk more about how we can make those decisions on what is corresponding. So when I see this example, it gives me 2 of our new symbols. We have the triangle shape, so we're saying triangle ABC is something compared to triangle DEF, and it's written out down here. So thinking back to our 2 symbols, this one has the equal sign in it, which means all the parts are going to be equal. So these 2 shapes will be congruent to each other. So that's what we're saying here. That means that all of the measures between these 2 triangles will be exact same numbers. So triangle ABC is how we named the first one. So since A was the first letter, and then D is the first letter in the second one, so notice how A and D are like the first initial of these triangles, those 2 angles will be the ones that correspond. So that means that angle A will be congruent to angle D. We can keep going with that and see our next one where we have angle B in the middle. E is also in the middle. So that means that angle B and angle E should be congruent. And I can mark them both with 2 arcs this time to show that in the picture. But down in my statement, I can connect angle E is congruent to angle B. So that only leaves us with 1 angle left in both pictures. And we have angle C, which was the last letter in the name. And that corresponds with angle F. And since these 2 triangles will be congruent, that means angle F will be congruent to angle C. So we're using the order of the name here to help us decide which angles are congruent to one another. We can also use this to help us see which sides are corresponding. So I notice here that this says AB. The side AB is connecting the first and second letter. So that means that'll correspond with the side DE in the second triangle. So AB and DE will be connected. So that means that the side AB is congruent to the side DE. Then we have the side EF being talked about. So EF are the second and third letter of its name. So EF would correspond with BC in the other one. So BC and EF. That means that we can say side EF is congruent to the side BC. So then that leaves us with our last pair of sides. And you'll notice we haven't highlighted DF or AC yet. A and C were both the first and third letter, just like D and F were the first and third letter. So that means that AC will be congruent to the side DF. So we just want to use the name of the triangles in order like that to help us make these decisions and pairings. So we're going to kind of repeat that, but for this 4-sided figure now, and we'll notice that the symbol in between them is a little different. So rather than these 2 shapes having the congruent symbol where it had the equal sign underneath, now that part wasn't given to us. So we are going to say that these 2 shapes are actually just similar. And so remember, when we say similar, it's kind of like they're just siblings. So they both kind of have the same shape, but they're not exact same size. We will know that the angles that are corresponding are congruent and that the sides will be proportional. So for angle A, I can see that that was the first letter in my first shape's name. That means that that will correspond to the first letter in the second shape. So A and G will be corresponding. So since these shapes are similar, angle A must be congruent to angle G. And one of the ways that you could mark that would be to put the angle markings on them. I'm going to do 4 on each of them because we have 4 different angles, and I'm going to draw that as 4 arcs. You could each give them 1 or 2, however many you want, but they just have to be the same between the 2 shapes. Then my next angle that they talked about was angle B. That is the second letter in my shape name, which means it will correspond with the second letter of the second shape. So B and H are both second, so those must correspond and be congruent in our similar figures. So angle B will be congruent to angle H. So again, you could add the markings. I'm going to add 3 this time on both of them. Then I have angle E over here. That one will be my third letter, which means it's corresponding to my third letter of the other one, which is angle C. So angle E is congruent to angle C. And then my last angle is angle D, which is the last letter, and it goes with angle F. So angle D and angle F will be congruent, and we can mark them on our diagram and write them like this. So we've now compared all of our angles that are corresponding. We can also compare the sides that are corresponding. So the side AB are my first and second letter. So I'm going to connect my first and second letter of my other shape. So that will correspond with GH. BC is the second and third letter, which goes with HE, which were the second and third letter of the second shape. Then we have EF, which is the third and fourth letter. So that'll go with CD. And our last pair of corresponding sides, we have GF, which is the first and last letter. So that will match up with AD. So we're just using the position in the names to help us match up those corresponding sides. We can also kind of look at it on the picture, where since AB and GH were both connecting the blue to the yellow angles, that could help us see it as well. And we can see that they both have the 4 arcs to the 3 arcs on those angles that we added. That's another way of identifying. So there's lots of options for how you can do it. So now we're going to determine whether these two triangles are similar. And so if they are going to be similar, then the sides must be able to be written in a proportion like we've been practicing. So we're going to try to write these two triangle sides in proportions. So the side LN is the first side that's given to us. LN is worth 4. And they're comparing that to the side SU in the other triangle. So SU will go here. SU is worth 20, so we're going to be able to plug those in from our picture. The side MN is worth 3, and the side TU is worth 15. So we're just pulling them right off the picture and plugging them into our proportion. So if these shapes are similar, then this proportion will be true. In order to check the true proportion, we can check the cross products are equal. So we'll take 20 times 3 and 4 times 15. 20 times 3 is 60, and 4 times 15 is also 60. So since their cross products are equal, we can say that those sides are proportional. Therefore, these two triangles will be similar. On our last example, we're going to try to find the missing measurement in a pair of similar figures. So it's similar to what we just did, but one of the sides will be missing, so we're going to have to solve for that missing piece. So we're going to look at the first example with these trapezoids. I noticed that I have 10 on top, which is the shorter of the two bases here. That's going to correspond with 15 in the second one. 14 and 21 are corresponding. And then our last pair, where we have 8 and 8, those will correspond to our x's in the bigger trapezoid. So you have a couple options of how you could write a proportion. We could write 8 over 14 equals x over 21. Or we could use 10 and 8 and 15 and x. So how I did that was I took my 8, which is from my small shape, and that was my green side. Then I put x next to it, which was the green side from my big shape. I compared that with 14, which was my yellow side from the small shape, to 21, which was the yellow side on my big shape. So on this left side of my proportion, I did all from the small shape, and this was all from my big shape. And then I did green over yellow. So I have small to small, big to big, green to green, and yellow to yellow. And I'm still able to make that hashtag like we talked about with our proportion word problems. And we're just going to solve this the same way that we have solved our other proportions. So we have 8 times 21, which is 168, and 14 times x, which is 14x. So we'll divide both sides by 14 in order to get x by itself, and we'll be left with 12 equals x. So that's one of the ways we could have set it up. We can also do it the other example with 10 and 15. So that's our blue and blue sides. And then we were comparing that to the green sides. So it doesn't matter if you pick the blue or the yellow, but you have to use green since that was our x, our missing side. So this one worked because on this first side, again, we compared the small sides, the small shape, and then we had the big shape. So these were both from the small shape. These were both from the big shape. This was blue and this was green. So we have our hashtag again. So if we cross multiply, we should get the same answer that we got in our last example. So we're going to check, and we have 10 times x, which is 10x, and 8 times 15, which is 120. We divide both sides by 10, so x equals 12. We got 12 as x for both of these, and so that's kind of how you can double check that you got it correct, but we have 12 centimeters for both of them. Then in our last example, we have triangle ABC is similar to triangle DEF, and we're going to solve for the missing side DE. So this side is our x value this time. So I'm going to again find my corresponding sides first. So 10 is the side AB. AB are the first two letters, which means they correspond with DE. So I'm going to highlight them both blue. So I can put blue and blue. We'll do it this way this time. So if I choose to put the blues on top of each other, I'll have 10 over x. That means on top, I talked about the small shape, and then on the bottom, I talked about the big shape. So whichever other pair of sides I decide to choose, I need to make sure that I put small shape over big shape. So if I decide I want to use BC, BC is corresponding with EF. So if I put those over here, I need to make sure that I have my smaller shape number first, which is 6, and then I compare it to my bigger shape number, which is 12. So we'll cross multiply. 12 times 10 is 120, and 6 times x is 6x. We'll divide both sides by 6, and we're left with 20 equals x. So let's double check it with our other one. We can say, if we're going to use 7 and 14 now, we can set up our proportion as maybe 10, or with our blue sides and then our green sides. But let's put big over small this time and see if that still works for us. So if I decide to put the big shape over the small shape this time, my big shape's blue side is x, and my small shape's blue side is 10. My big shape's green side is 14, and my small shape's green side is 7. So if I cross multiply, I get 140 equals 7x. I'll divide both sides by 7, and I'm again left with 20 equals x. Sorry for the bell. So that is how you can go ahead and set up your proportions in order to find the missing sides. So it's very similar to how we were doing our proportions before, but now we're just comparing big shape to small shape and which sides are corresponding.